Esteemed Dean, School of Upper Learning, Professor M A Sofi, Worthy Director, Directorate of Distance Education, Professor Shah, respected Chief Guest, Professor M A Sofi, and other professors from the Directorate and Department of Mathematics, and dear students, good afternoon. I welcome you all on this extension lecture, How Mathematics Trains the Minds to Think. Dear friends, Professor M A Sofi need not any introduction, but for newly admitted students, I will just brief it. Professor M A Sofi has done BSc from University of Kashmir in 1974, MSc from AMU 1976, and PhD from IIT Kanpur in function analysis in 1982, and then he has done postdoc from Germany. Professor M A Sofi has 38 years of teaching experience. He has started his career of teaching from IIT Kanpur as a teaching assistant, then moved to the AMU as lecturer, then reader, and then joined the University of Kashmir as a professor in 1991 up to 2014. He received emeritus professorship in 2015 up to 2018. He was presently as NBHM visiting faculty for JKIMS Institute. Professor received Dal Fellowship and Ramanujan Prize. He visited all over the countries. Now I request Professor Tariq Ahmad Chasti to kindly welcome Professor M A Sofi.
Good afternoon. Professor M A Sofi, former head, Department of Mathematics, former Dean, Faculty of Science, and today's speaker, Professor Shaukat Ahmad Shah, Director, Directorate of Distance Education, Professor Pirzada Sharifuddin, former head and Dean from Department of Mathematics, Professor Mushtaq Ahmad Dar Sahab from the Directorate of Distance Education, and dear students. So I, on behalf of Directorate, welcome all of you on this occasion of an extension lecture to be delivered by Professor M A Sofi on the topic, How Mathematics Trains the Mind to Think. So it's a very catchy subject, and I hope you will give the patient hearing to Professor Sofi. As Rizwan was introducing Professor Sofi is from Kashmir and is one of the pioneers in mathematics from the North India. He did his PhD from the prestigious institution IIT Kanpur and then went for the postdoc fellowship to West Germany. So after completing the postdoc fellowship, joined the Department of Mathematics, first in the Applied Mathematics in the Aligarh Muslim University, and then the Department of Mathematics as assistant professor, and then subsequently became the associate professor. At that time, we used to call that reader. So, and I was a student. I am very fortunate enough that I was a student of Professor Sofi when Professor Sofi was in Aligarh, and then he joined the Department of Mathematics as a professor in 1991 as a young professor and the long-serving professor in the University of Kashmir. He remained at various positions like Dean, School of Sciences, then as Dean Academic Affairs, and was the acting Vice Chancellor for quite some time. So his contribution to the subject of mathematics, particularly in his field of specialization, which is analysis, functional analysis. So he has delivered talks all over the world and has published the papers in the reputed journals. So we are very fortunate enough that we have with us Professor Sofi and the students, the fresh students which were admitted for the first semester for the year 2023. So you are very fortunate that you are receiving the first lecture from Professor M A Sofi. I hope you can have the love for mathematics, and since you have opted mathematics for master's degree, means that you can have the career in mathematics, and I hope that this lecture will help you, because extension lectures, they are the integral part of our learning process, distance learning process. In the distance learning process, we don't have only to face-to-face teaching, we can have the multi-dimensional things in that. And one of the things is that you can have the interaction with the eminent professors face-to-face, and you can interact with them. That's very important thing for the students. And I hope that today's lecture will give you an idea what mathematics is all about and how we can use mathematics, and how we can think differently when you are doing mathematics. So I once again welcome you and welcome Professor Sofi. Thank you very much.
Assalamu alaikum, all those present here. I would like to begin by thanking the Department of Distance Education. Does it continue to be called by that nomenclature? Directorate. For this kind invitation, and the director of the center, Professor Shaukat Saab, Professor Tariq Saab, and Dr. Rizwan for having taken the initiative to get me here and interact with the audience here. To begin, I'm not very sure if there are people from outside the center, or are there?
Yeah, there are some students from mathematics.
Okay, but not from the from outside the university. All right. So, I shall try to be as non-technical as I can, even if the fact remains that most of you are exposed to a certain level of mathematics. But my idea is not to talk mathematics, but talk about mathematics, certain aspects of it at least. And as the title indicates, how a training and instruction and education in mathematics helps you to develop clarity of thought, conviction, how it trains the mind to think, in other words. So, well, before I come to the brass tacks, I would like to, clarify one thing. I mean, this is one of the mathematics. Obviously, I'm not making some rocket science statement. It's one of the thousands of other intellectual disciplines, which includes sciences, humanities, arts, and all that. But there is something which is very, very peculiar to it. And you see, this is about the only intellectual endeavor that doubles up as a discipline, as an art, as well as a science. So, ये तो रही इंडिया किसी और मजमून का हासिल नहीं है. And for reasons that I am going to elaborate on. There are, noises being made by critics, by skeptics, by cynics. Well, it's all knowledge, pure abstract knowledge. I mean, why do it? In fact, the other day, some of the motivations have come from a few posts that I saw on the Facebook, and I was partly amused and partly surprised because those guys happen to be exposed to a certain level of mathematics. So that could be perhaps part of the motivation. You see, Facebook is not all that bad. In fact, that has motivated my today's talk in a way. You see, we humans are endowed with the intellect, with intelligence, the capacity to think, which is certainly not shared by any other living species. So that goes without saying. There is a certain level of intelligence even in animals. In a dog, for example, in a swine, we are endowed with a certain level of intelligence. So what use is this intelligence? Is it supposed to be employed only to make our lives more comfortable, happier, easy? Is intelligence supposed to be employed for such things only? All I'm trying to say is to make distinction between pursuit of knowledge for its own sake and then the utilitarian aspect of education, of knowledge. Something that we can use. I mean, you see some very good, successful individuals in science and humanities. What use is doing this theory? What use is for pursuing this particular discipline if it doesn't help me to improve my living conditions? Isn't it? This is what most of us say. My contention is that since we are endowed with a certain amount of intelligence, in fact, we are super intelligent in evolutionary terms, we have to use our intelligence for a higher cause, much higher than using our knowledge for utilitarian purposes. So that way, if I talk about mathematics, if I talk about religious studies, if I talk about even theoretical psychology, education, philosophy for that matter, history, these are all theoretical disciplines. They don't have much to do. I mean, there is something called experimental psychology, leave that alone. So according to this perspective, those things are better avoided. I mean, what use are they? They don't. Okay, how does it improve my life if I know what had happened in history in the past, which events had happened? What is the big use? And why do I have to study philosophy? Philosophy deals with questions which are beyond our ken, which are beyond our reach. Why should we do it? Whether God exists, how does it matter? What is morality? What is ethics? What is beauty? What is ugliness? So these are the kind of issues that in philosophy, we try to grapple with. So on the face of it, they are no use. But this is very, very essential, vitally important for the human being. Because he is born intelligent. He has to think about things, why they are the way they are. So, pursuit of knowledge for its own sake is already a noble pursuit that we cannot do without. There is technology which we employ in our daily lives, which is an offshoot of sciences, and sciences in more ways than one depend upon certain theoretical underpinnings, theoretical foundations. So these theoretical sciences have to be, or theoretical studies have to be pursued alongside what passes for technology, right? That has to go with this. But there is something common in theoretical studies. In fact, by very definition of theoretical studies, they are not applicable in our daily lives, are they? As I just said, the kind of issues that we grapple with in philosophy has no bearing on how we live our lives on the planet. But mathematics is one discipline where the pursuit of theoretical ideas leads to applications. It impacts our lives in 1,000 odd ways. Uski kya wajah hai? So how do we distinguish philosophy or theology or history from mathematics? I wish it was an interactive thing and someone in the audience would say, could this be possibly the reason? I wish it was that. If there is any one side, he can come up or she can come up with this idea. So, what is so special about these theoretical constructs of mathematics, which is not so in other theoretical disciplines? The answer is that in mathematics we deal with abstract entities, abstract objects, absolutely abstract categories of objects. God, existence of God is also an abstract thing. Isn't it? It's abstract. I mean, to what extent can you make sense of this question or answer it? What is God? Does he exist? If he exists, is he unique? Things like that. While mathematics finds applications in spite of being such a pure abstract discipline, the reason is that the more abstract an idea, the more abstract a concept, the much deeper its level of abstraction, the more is the potential for it to be applied. And that's the surprise. वो तो एक मुअम्मा भी है, एक मुअज्जा भी, which we know that these are the answers, but why are these the answers to these questions? We don't know. So, what is common to theoretical studies is this important fundamental principle. As human beings, as intelligent species, living species, if we can know, C-A-N, if we can know something, then it is criminal not to know. If we can know something, then it is sinful not to know. If we can know something, then it is immoral not to know. That is what distinguishes the humans from other species. We have got to know. Curiosity has to kill us, otherwise we are not humans. Of course, we will wonder about this. Why is it working? We are carrying the entire universe with us, and we can access any damn thing at the press of a button. So the principle we can understand, all of us can understand. But there is a theoretical underpinning to that. As I said, it's common to all the gadgets, all the technology. And here, of course, it's some basic elementary mathematics that tells us why it's so. So the burden of my song is that mathematics is not important because it finds applications in all sciences, all technology, or it is the language of science. No. It has to be pursued for its own sake. इसीलिए मैं ये बार बार कहता रहा हूँ, controversy number 2. I'm quoting controversy. Many people, including Ansar, may perhaps disagree with me. शायद इनसे कभी बात हुई थी बीच ऑफिस में. Long way back. अगर हम इबादत सिर्फ इसलिए करते हैं कि हम जहन्नम से बच जाएं और जन्नत के अंदर दाखिल हों, मैं उसको बहुत जबरदस्त इबादत नहीं समझता जाती तौर पे. It has to be, this ibadat has to be based on our love for God. बाकी वो जाने, तू मुझे कहां फेंकता है, इधर या उधर, मेरे साथ कैसे डील करता है, ये तेरे ही ऊपर है. ये नहीं कि साहब pursue things for their own sake. And not surprisingly, when we pursue mathematics for its own sake, the amount of benefits it delivers in return are mind-boggling. I'm going to tell you something at the end, hopefully. A discovery was made about a couple of years ago in mathematics, and that Ukrainian lady, she was awarded the Fields Medal, which is the mathematics equivalent of Nobel Prize, and her ideas were used in the Voyager, or deep space communication. उनकी जो मैथमेटिक्स जो उन्होंने की थी, it is so abstract. I mean, we are brought up, bred and brought up in doing abstract mathematics. हमारे भी हवास बागता हो जाता है उस चीज को देख के, how abstract and how removed from reality it is. But perhaps that is the reason. The more abstract it is, the more immediately it finds applications. It was a matter of just 2 years after that discovery that NASA had sent a mission, the Voyager mission, and then the deep space communication involving sending pictures and messages was possible only through what's called the GOLAY code, G-O-L-A-Y, which was a consequence of her discovery into what's called the cipher packing problem. Extremely difficult area of pure mathematics. Extremely difficult. I mean, I am not able to, make sense of it in its entirety, what it is, but it has found applications. So, love for love's sake, without expecting anything from return, that is the name of the game, and that's what delivers in mathematics, and that is why we should be doing it. Okay, so this was only the introduction, so you can understand now how long it will take me for telling other things. So the mind is best trained by understanding what is learned. That is the first takeaway. The mind is best trained by understanding, not merely by understanding, but by understanding what's learned. So I have put down these 3 very important quotes by 3 great people, Whitney, Benjamin Disraeli, and Simone Weil. The first one is very important, especially for the students. Intelligence is proved not by the ease of learning, but by understanding what's learned. You see, we learn things by heart, which is the greatest undoing of modern education. You see, whenever we issue a date sheet for the students, so in case there is not sufficient time, so students always want कि 15-20 दिन चाहिए. So we do it in most of the cases. अब किसी वजह से, I mean in the years gone by, जब हड़ताल बहुत हुआ करते थे, तो the examination would not be held on that particular date. So once we had issued the date sheet and some mishap had happened, 2-3 दिन का हड़ताल वो रहा था, and the examination could not be held. The students came to me कि साहब उसको आप postpone करें. मैंने कहा postpone तो हो ही गया, ये तो करना ही है. दूसरे दिन उनका एग्जाम था, तो पहले ही मालूम हो गया था there was going to be हड़ताल, and I said okay, we'll do it. तो I had a look at the calendar. I said चलो मान लीजिए उस दिन अगर 10 तारीख थी तो मैंने 14 की रखी थी, something like that. तो स्टूडेंट से नहीं 14 नहीं, मैंने कहा फिर क्या 11 को रखो. अरे नहीं साहब, you have to do it either on 12th, 11th or 12th, which we couldn't do for some reasons, not 14th, then do it on the 28th, पीछे. मैंने कहा इसका लॉजिक क्या है? And you understand the reason? You must be understanding. उनका ये कहना था कि जो हमने मेमोराइज किया है उसकी शेल्फ लाइफ 2 दिन है. अगर 10 को नहीं होता है तो 11 को होता चलेगा, 12 भी चलेगा, 14 में तो 4 दिन है. So it will go away from our heads. So आप कह रहे हैं कि आप इसको 14 को रखिए, वो नहीं चलेगा. तो आप फिर आप 28 को रखें, हम इसको फिर से जो है वो. So this is what happens, when you cram things. when you remember things by rote. So you do learn, definitely you do learn. You do learn, but it is learning by rote. This is not intelligence. That in quick time you are able to memorize sheets of papers, volumes of books, and then park them somewhere there. मैं वैसे रश करता हूँ आप पे, आप कैसे ये याद करते हैं, किस तरीके से करते हैं? I mean, I have never been able to do it. I never ever can do it. Even during my student days, I was not able to do it. So it's not the ease of learning, how quickly you can memorize, but by understanding what's learned. Understanding is the name of the game. Everywhere, but more so in mathematics. You see, here again, mathematics stands apart from other disciplines. Leave alone the humanities. Even if I compare it with other sciences, let's say life sciences or chemistry. So, if a teacher is teaching a certain topic in a class, and this topic is supposed to be covered in 3 or 4 lectures, and if by some chance student skips one of the classes, he comes the next day, by and large it's possible for the student to cover what has been lost, and he can do a self-study and then make sense of what was lost, and he can connect things. यहाँ का अलमिया ये है मैथमेटिक्स में, if you lose the class, unless you make up for it on your own, either you meet the teacher, you see the teacher के साथ ये छूट गया था, इसमें मुझे बताइए क्या करना है. If you skip it or you memorize it for the sake of exams, वो जो खलीज है, सुश जहरबाद बना हुआ है period. You see, it festers like a sore, it becomes an abscess. You see, mathematics is an organic whole. There is organic unity in it. Everything is connected to every other thing. Again, something very, very peculiar to mathematics. What the Greeks had done 2,500 years ago, we want to know it now if we want to understand what we are doing at the moment. उसका हम बस कुछ में नहीं डाल सकते. Unless and until how to draw two, let's say, two circles which are tangent to each other. We have to know it. It was Euclid's geometry. We should be able to do it. How to divide a line segment, how to divide an angle into 2 parts or 4 parts. Unless and until we know that, it's all useless. That's not quite the case in life sciences, in chemistry, even in physics or elsewhere. You see, classical mechanics comes in handy if you want to know modern physics, quantum physics. That's very good. But if by chance you have missed out on classical physics, you can still take up a study of quantum mechanics. उसमें खैर उस तरीके की बात नहीं होगी if you knew what Newtonian mechanics was. So if you have a background, a solid background in classical, you will be able to enjoy quantum mechanics. But understand, you can nevertheless. In mathematics, that just cannot happen. That cannot happen. So this is one of the reasons what leads to what's called math phobia. Math phobia किस चीज को कहते हैं? Math phobia is not something very esoteric. It happens because when a student skips the class, or the teacher is not able to make his stuff intelligible to the school child, and school child doesn't have that much maturity to ask the right questions. So that gap is left unfilled at that point of time. Then the student is promoted to the next level. He is exposed to a slightly higher level of mathematics. But it is Benjamin Disraeli. What do we do in mathematics? Saying much, struggling much, and studying much. These are the 3 pillars of learning. Nothing comes for free. As Americans say, there is nothing like a free lunch. So, actually, this struggling should have been the last. Saying much, studying much, and struggling much. ये बिना स्ट्रगल के नहीं होता. मेरी रातों को आंख खुल जाती है, even at this fag end of my, I don't know, life, but yes, career. Life का भी अल्लाह ही मालिक है, but you still struggle. I mean, I do find myself struggling. And my wife says you are struggling like a high school student. This is her refrain when she finds me in my work. So struggle, we have to struggle. Without that, you can't. And joy of learning is as indispensable in study as breathing is to running. You see, every time we run, we breathe, isn't it? It never happens. Learn करने के लिए काफी मशक्कत करनी पड़ती है. But that moment when you learn, that aha feeling, AHA, that gives immense amounts of joy. ये जो हम क्रिकेट देखते हैं या ये सब चीजें जो हम देखते हैं, I mean, we always love the moments, those fleeting moments of glory. But the struggle that they have to go through, how they have to train themselves on the nets, at the nets every single day, every single moment. जो हमारे favorites इतना सब नहीं करते ज़्यादा, तो which is what has happened with them. But this is what's extremely important. Discipline, which is definitely Now, you see, something called math literacy. What does it mean? Math literacy. So, my current contention is that regardless of whether you pursue a career in mathematics or not, as a teacher or as a researcher, regardless of whether you are a computer scientist or a technologist or a doctor, an engineer, or even a driver or a plumber, a certain amount of mathematical literacy, not mathematics, deep background in mathematics, mathematical literacy is needed. So again, recently, someone on the Facebook, just a couple of days back, and he had written down these three fractions. And the answer in each case on the right hand side is the same. And this happens all the way up to 9. He says, you see, these are 6 digits up and 7 digits below. The same digit 1, 1, 2, 2, 3, 3. And if you do the same thing for 4, you get the same answer. You do it up to 9, you get the same answer. Apparently very surprising, isn't it? So he said, I mean, he's a well-educated person, no doubt about it. Well-educated, I know him. And he says, isn't it really amazing? And his joy knew no bounds. I don't take away anything from him. But math literacy would tell him, well, it is just one equation, the first one. Others are the same as the first one. You simply have to cancel out 2 from the first 2, from the second. Cancel out 3, which is common. Cancel out 4 for the next. And he was abundantly surprised. He said, अरे साहब कमाल है, क्या पैटर्न है इन नंबर्स का. Same number repeated 6 times in the numerator, 7 times in the denominator, and you get the same answer. So the thing is, it's the same thing. So all I'm trying to say is that it doesn't merit being posted on the Facebook and then express surprise. पहले में बहुत सारे लोग थे friends, सब लोग बोले साहब अरे क्या कहने मैथमेटिक्स के. I mean, this is ऐसे ही कि जैसे मैं कोई शायरी कर रहा हूँ उस पर आप गान देने लगे. And so I didn't comment on this, but someone else did it. तो मैंने उनसे कहा कि भाई it's the same thing, there's no surprise. You simply have to cancel out the common factors from the numerator and denominator. And then I will leave alone this birthday problem, which will take me a little while. Well, look at your keypad, your mobile keypad, and you will see one thing. See 1, 2, 3, 4, 5, 6 up to 9. If you add these, I mean, if you take any row or any column, how many of such? 6. 3 rows and 3 columns. and you take the diagonals. You get 8, 3, 5, 7 here and 1, 5, 9 here. What is common to all these? You see, if you write each of these 3-digit numbers and then adjoin to it the same number in the reverse order. For example, if it is 1, 2, 3, you write the new number as 1, 2, 3, 3, 2, 1. Right? Like in the first row it is 1, 2, 3, then 3, 2, 1. So it's a 6-digit number. The third one is 7, 8, 9, 9, 8, 7. And then diagonal is 1, 5, 9, 9, 5, 1. So these 6 digits or 8 digits have 8-digit numbers have one thing in common. And what is that? They are all divisible by 37. They are all divisible by 37. Surprised? Of course surprised. Each one of us. क्या है इसमें? I mean, जब उन्होंने मोबाइल सेट बनाया था तो उसमें उनके जहन में ये नहीं था कि इस तरह की गेम भी होगी उसमें. It just happened. Again, a certain amount of math literacy tells you why it's so. So if you know how to write a decimal, how to write a number in decimal form, then you can check it that it always happens. You see, all of these 3 digits are in what's called arithmetic progression: 1, 2, 3, 4, 5, 6, 7, 8, 9, and then vertical and also diagonally. And use this property of arithmetical progression, you can show that 37 is indeed the sacred number which divides all these numbers. This was another surprise on the Facebook. कि साहब देखिए हमने ये पैटर्न डिस्कवर किया. There's nothing. Apparently there is something. It's a big deal. I mean, tell even a highly educated lawyer or a doctor कि साहब ऐसा होता है. Oh, you will say ऐसा. Definitely it happens, but then there is no such great pattern behind. You have to do a couple of lines calculation and tell yourself that it's indeed so. So now here is another chestnut, the chessboard problem. The chessboard problem, again I tell you, a certain amount of mathematical literacy will stop you from falling into the pit. You see, the problem is like this. Please hear me out. Shaukat Sahab owes me 10 lakhs, let's say, to make things. आपके पसीने छूट गए. So he's saying कि साहब मैं आपका ये चुका नहीं सकता for some time. 5 years, 7 years, मेरे पास उस वक्त वसाइल नहीं है. So I tell him, चलिए आप ऐसा करें, मुझे तो पैसे की जरूरत है, तो why don't we do one thing? Please hear me out. I mean, this is so simple looking. I get a chessboard. इसके अंदर कितने खाने होते हैं? Squares? 64. I tell him, आप ऐसा करें, 2 महीने के बाद आप मुझे थोड़ा सा लौटा दें. He says, आप 2 महीने के बाद I cannot give you 10 lakhs. Maybe 50,000. It's a pittance. And I tell him, chalo theek hai. But he says, I will not give you in cash. I will give you in kind. मैं जी आपके लिए राइस दूंगा. So what I tell him, आप ऐसा करें, you get your rice and you count 64 days from tomorrow. What you have to do is to put 1 grain of rice in the first square. Not 1 kg or 1 gram or 10 grams. 1 grain of rice. The next day you have to do 2.
Double.
You have to double it. Third day you have to do double of this. So it will be 4 grams. 4 grains. Then it will be 8 grains. Then it will be 16 and so on and so forth. I tell him, आप ऐसा करें. भाई जी आप करेंगे? शौकत साहब करना चाहिए. I mean, that's what common sense should. So he readily agrees. Of course, I mean, You can't fall into it. But anybody else would. So he does it. 64 means 2 months and 4 days, and he gives up early enough. Just 1 महीने के बाद सब मैनेज कर सकते 50,000 से ज्यादा इनको लग रहा है. अब कितना ज्यादा है? Look out for this. So this is खसारे का सौदा इनके लिए, and here is the reason. As he goes on this chore happily in the first few days, lasting over a week, the second week and the third week, he soon begins to wonder whether that was the right call for him to take. In fact, assuming that the price of rice is pegged at a meager amount of 50 rupees kg, it soon begins to dawn upon him that at the end of only the 20th day, he has already parted with a quantity of rice that's already worth far in excess of the money that he actually owed me. Now, how much is that? Again, I'll cut it short. On the 64th day, you know how much grain he would have put on the board? A simple calculation, which needs a modicum of math literacy, shows that it's a mind-boggling so many tons, 12-digit metric tons of rice, which is far in excess of 503 million metric tons, which was projected to be the total world rice production in 2021. I mean, I would have imagined, let me tell you, हम बड़ी ये बातें कर रहे हैं मैथ लिटरेसी की. I would have said, नहीं साहब 10 दिन का कर दीजिए, तो थोड़ा सा अंदाजा हमें हो जाता है कि 1 महीने का बहुत ही खसारे का सौदा है. So 1 metric ton is 1,000 kgs, and it is so many metric tons. It is such a prodigious number that I can't even begin to read it. It is a 12-digit number, so many metric tons, which is in excess of only 503 million metric tons. So it is 384,307,168,202 metric tons. Can you imagine, by the way, unless you put the time to the paper. So this is something, it won't come as a surprise to anyone who has a basic course in mathematics, but exponential. So, what is at play is the exponential increase, yes, what we call the exponential increase of the quantity of rice. And there are many such stories to share, but so that's one side, as I said, math literacy. So let's come to this. What do we do in mathematics? Apart from that, the importance of math literacy at every level. Search for order behind apparent disorder. I'm going to demonstrate it by a few examples. So, there is orderliness, there is discipline, there is a pattern lurking behind everything that we see on a daily basis. So, I quote here Francis Su. He was the president of the Math Association of America, and he has written some very, very gripping articles on this theme. And in one of his quotes, he says that pursuing mathematics as part of an effort to pursue beauty and elegance cultivates the virtues of transcendent joy. And he says, by joy, I refer to the wonder or awe or delight in the beauty of the created order. By transcendence, I mean the ability to embrace the mystery of it all. There is a transcendent joy in experiencing the beauty of mathematics. It's not ordinary earthly joy. If mathematics is for human flourishing, we must help others see its beauty. So there are hundreds of such examples, but I have isolated a couple of them, and these are taken from first course in graph theory, of which we have an expert here, Professor Firzada. He has been working on this thing successfully for the last several years. And you see, we are about 100 people here, or 100 odd. How many of us know each other? It could happen that none of us know each other. Supposing I was taking a flight from Delhi to Timbuktu or to Casablanca, there are feeble chances that I might know someone over there, or anyone sitting in the plane would be knowing anyone else. So this is just possible. But there is something very interesting. In any group of people, just 6 of them, you will always find at least 3 people who are either mutual friends, mutual acquaintances, or strangers. It needs a little thought, a moment's reflection. What does it really say? At least 3, at least. I mean, if 6 friends are sitting at the table, all of them know each other. So 3 is the minimum. Or if 6 people are walking on the streets of Srinagar, they may not know each other at all. But 3 is the minimum. So you pick up any 6 people at random. One from New York, one from Srinagar, one from Baramulla, one from London. Go on doing it 6 times, you will find 3 people who are friends or strangers. Do you find any surprise in it? As in the previous paragraph, Francis Su says, there is constant joy in experiencing the beauty of mathematics, and if mathematics is for human flourishing, we must help others to see the beauty of mathematics. So there's a lot of surprise in store. In a group of 6 people, you will find 3 people who are either strangers or friends. You can do this experiment right away. Let there be 2 people from this row, 2 from there, 2 from here. Are they clear? Put 2 people gather from there. One and another. Yes. आप में से 2. Yes. कोई और? आप में से girls. Yes. Just get up. Yes. बताइए आप उसमें strangers हैं, friends हैं? Is there a friend?
Yes.
You are friends? You 3 are friends? तो हो गए. So there are either at least 3 friends or at least 3 strangers. And I tell you, it's extremely exciting. And does it mean, well, this is the end of the game? You see, what stands out for mathematics is to look at the patterns, no doubt. But at the same time, to build theories surrounding, let's say, this particular phenomenon. What does that mean? To locate this small, apparently small phenomenon as part of a much larger theory, so that this follows as a simple consequence. There is something called the pigeonhole principle. You know that?
Yes.
At least those who are in mathematics, they know it. But then for the non-starter, you know what's the pigeonhole principle? It is what it ought to mean. For example, I have 10 pigeons and there are 10 pigeonholes only. So what's the conclusion? The conclusion is that there will be at least one hole which will have to accommodate 2 pigeons. As simple as that. As innocuous, as harmless a statement as that. This is something which comes in very, very handy in deriving some profound theorems in mathematics. I'm going to quote at least one of them later. So this is the pigeonhole principle, which is very useful in mathematics. But more than using this as a principle, as a building block, or as a foundational technique to derive certain mathematical conclusions, as a mathematician, I have to try to develop a theory where it could be located as a special case. Alright, that is what has actually happened. There is something called Ramsey theory, which is a huge edifice of combinatorial, of graph theory, combinatorial mathematics, where it can be located as a special case. Ramsey theory, I mean, there are different versions of Ramsey theory there. At least dozens of them. How many are there? Dozens of them, and some very profound, very deep, and very difficult. And some of the apparently harmless looking problems have not yet been solved. For example, Ramsey numbers, so-called Ramsey numbers, have not been exactly computed even in the first few cases. So this pigeonhole principle sits there as a small item in that bigger claim. That is what is the bread and butter of mathematics, of mathematicians. So, so this is a very nice example of how mathematicians look for patterns and discover them. And the proof of this friends and strangers theorem is some simple mathematics involving a basic course in graph theory. Something called the coloring and all that, and a certain graph, complete graph K6. So some properties of that, and that will give you that conclusion. Now there is a
particular thing our intelligence increases, or is it kind of inert? Like intelligence, is it inert? Is it seen like I would see, is it kind of genes or something, or does it improve by eating something? That's my first question.
So I'll answer this first. I never said that this is the determining factor in terms of intelligence or any other thing. You see, generally we say you are what you eat, and you are as a person, as a sum total of flesh and blood. You are what you eat. But as a human being, as a man, or as a human, as a member of the human species, you are what you think. So in that sense, I made these comments. Eating certain things does help to improve our, say, memory or our common sense or our intelligence quotient. They do to a large extent. Well, that's no reason to say that since this increases our intelligence, therefore we should go for this. It's not that. In fact, there are many reasons. There are cultural reasons why a certain community happens to be more intelligent and more successful, as you said. Has been the case with Jews, not now, but even our scripture says that they were the chosen people for some reason. So these are very complex issues. Why has a particular community been identified as the chosen people at that point in time, and special people endowed with certain faculties? So those are very that's a different set of reasons. But as I was saying, what you eat does help. For example, we are told by doctors that if you have a certain amount of almonds every single day, it improves your memory, right? And if you have lots of fruits, it improves your metabolism, your digestion, and things like that. So उस तरह की चीजें हैं. For example, protein is supposed to be good for those who are carrying fatty liver, but it leads to uric acid.
Yes.
But you should put down. So it breaks your bones, but then it has other advantages. And well, there are, as I said, there may be at least some advantages in eating pork. But then there are other things why we tend to avoid.
So my next question is, sir, as far as physical knowledge goes, it comes from, I'd say, it comes from outside world to inside. Like we see in nature, we see physical laws, and then we kind of make the laws. Like when somebody saw apple falling, so he tried to understand the nature, and that's how laws of gravity came into physics. Is mathematics kind of knowledge which comes from outside world or is from inside? What I mean to say is mathematics discovered or is it invented? So if it is invented, then why would we say like there's no real number whose square is negative? Let us say there is a number. So we kind of define ourselves. That suggests that we are inventing it, we are not discovering. So I'm just baffling with this question, and this question always baffles me. So I want to know the answer.
All right. Well, the first part is a very useful question. Whether it is discovered or invented, that's not a very important thing to spend our time on. I'll come to that later. But the first part is, where does the inspiration for mathematics come? Does it come from within or from outside? Again, mathematics stands out. Good mathematics has been created by people who are completely divorced from this society. There were, there were people living in the caves who came up with great theories of mathematics. But then, there are great theories of mathematics in contemporary times which have been inspired by the physical world. For example, there is something called algebraic geometry. It's a very active and a very difficult subject area of mathematics. And there have been many open problems which man has not been able to unravel or get into. On the other hand, so-called string theory in physics, which deals with which is supposed to deal with the physical world, right? Physics, which deals with nature, with the natural world. While doing string theory, people did come up with certain situations which gave them some hints, some idea how to tackle those abstract questions which were encountered in algebraic geometry. So it could be both ways, and it is both ways. So a man living in a cave can produce great amounts of work in mathematics without knowing what's happening outside. And then there are also inspirations which come from
Outside.
There are both inspirations. And many. There are too many such instances.
I think, sir, we should
Are
accept.
you done? Yes, please.
We should,
Please go
we
ahead.
should accept both things. It's discovered as well as invented. Because sometimes the questions arise like this. As I mentioned, there are imaginary numbers which help us deal while dealing with this engineering rotation. But when we explain it to the students, we explain it in this way, like there is no natural number whose square is 2. Let us define a number. So we kind of are defining. So it kind of feels like we are defining it, we are inventing it. It feels to the children at that time.
देखिए ऐसा भी नहीं है. Well, it's an interesting aside that you have made. It's not that since no real number squares down to a negative number, that we know that's a fact, but then perhaps we needed, as you say, something which upon being squared should give me a negative number. ऐसा नहीं है कि चूंकि वहां पे जरूरत पड़ गई इसलिए हमने ऐसा किया. There were other pressing reasons for us to create a new theory, the theory of complex values.
We're creating it.
Yes, this came up. I mean, this came up as a natural question. For example, how did complex numbers come into existence? There is a huge history behind it. How did they come up? But certainly this was not the motivation. Since we need a number whose square is, that was not the motivation at all.
Basically, for a non-mathematician, it can be an imaginary number. But there's nothing
It is
like
not.
imaginary in
It
mathematics.
is not.
And secondly, if Newton was not born, apple will still come down, it will not go up.
I understand the necessary truths and the contingent truth. I understand those things. The physical laws which are true here on our earth, they may not be true for other worlds. But our mathematics is like, it's necessary truth. It's everywhere true. If we were not alive, still 1 plus 1 would be 2. If we would not be on this earth, still 1 plus 1 would be 2. So it's a necessary truth.
So I square equals minus 1, it is not something that we need it and so therefore we need it. It came purely from pure mathematical considerations. Purely from pure mathematical considerations. And the depth of the idea was so overpowering that complex analysis, complex numbers became the very language of say, classical physics.
Yes.
Electromagnetic.
Yes.
It is the the profundity of its depth as a mathematical construct. Yeah, there was a question there.
We are speaking in a language, ordinary language, natural language. Why mathematics need to translate into numbers or notify things? Is it necessary or is it not necessary?
I didn't get it.
So language we are speaking. So we are also doing things in it. Mathematics means dealing with the concepts, facts. So if we are so mathematicians or logicians, they are translating into numbers or into something representative. It is necessary that the number appears as reference, or it is just a symbol.
You see, mathematics actually deals with certain thought categories involving numbers, configurations, space, etc. So the categories of thought that it deals with come from numbers.